It's homework time. Homework time is here again. Happy days are here again. Well, let's start off this lesson 13 of Module 1 homework by You Got It. Let's write our names at the top. I will write my name, and you write yours. And if things worth doing, it's worth doing well. So let's jot down the date. I will write today, but you write the actual date, where and when you are. So let's jump right in. Subtraction is the name of the game in lesson 13. And we start off, you see we have 6 here and then a few more. Just straight on subtraction using the standard algorithm, the usual way of figuring things out. So let's do it. Let's just subtract. All right, let's look at A. We have, we're starting with 2,431 minus 341, and we will not be confused by that. In fact, if you take a look at B, C, and D, it seems to be using similar configurations of that 1, 2, 3, 4, but we will stay on top of it. Let's begin. 1 minus 1, you got it. Don't forget we're subtracting here, switching over, is 0. Now 3 minus 4, when we look at that, if you need to, go ahead and hold up 3 fingers and say, I cannot take 4 away from that without regrouping. So I go over, I will need to do something with this 3, I go over to the hundreds place, and I take 100 from that, and I bring it over here to the tens place, and just to take a moment to point out that 13 tens, remember all of our place value work, 13 tens, is 130. So that 3 that had a value of 30 in the tens place is now 13 tens, 130. And we're subtracting 40 from it. So this all makes sense. It's a beautiful thing. But we can just call it 13 minus 4 to keep life simple, which we know is 9. And then 3 minus 3 we can handle, yes, 0. And then we have just the 2, which we're not subtracting anything from in the thousands place. And a quick look will tell you that our answer makes sense. 2,400 minus 300 is going to be about 2,100. Our answer rounds off to 2,100. Let's look at B. Again, we have the 1, 2, 3, 4 thing going on. So let's start off. In the ones place, 1 minus 1 is, yes, still 0. 3 minus 2. Got it, 1. 4 minus 3, also 1. Now we go to do 2 minus 4. Okay, we see there we need to regroup here. So we'll have to do something with this 2, and we go over to 10,000s place, and we will leave 1 there and bring it over here to the thousands place. And so now we can look at this as 12 minus 4, which indeed is 8. Might as well insert our comma now while we're at it. 1 minus 1, ever and always 0. And then 4, we're not subtracting anything from. So again, does the answer make sense? 422 minus 14, well, 22 minus 14 is 8, isn't it? Yes, so 408. So this answer makes sense, 408,000. Now over in C, we again have the 1, 2, 3, 4 going on, but we're throwing in a 0 and a 9. Spice things up a little. So 1, taking away 0, we still have 1. 3 minus 2, you know that, it's 1. 4 minus 4 leaves 0. Likewise, 2 minus 2 is 0. Let's insert our comma while we're here. Now when we go to do the next one, we say 2. We can't subtract 9 from 2 without doing something first, a little regrouping action. So let's say we need to do something with this 2. We go over to the 100,000s place, leaving 3 there, and bring it over here. So now we're doing 12 minus 9 leaves 3. And from this 3 we're subtracting nothing. So that remains a 3. And again, to look at it, 422 minus 92. Well, even if we round it off to 420 minus 90, or even get rougher with it and just say, well, 400,000 minus 100,000, which isn't what the numbers round to, but just to give it really rough, around 300,000. You know you're in the ballpark then. Usually when you're wrong, you're way off. All right, let's look down at D here. So we have 1 minus 0, leaving 1. 3 minus 2, again leaving 1. 4 minus 4, yes, that's 0. 2 minus 2, likewise 0. Let's insert the comma while we're there. And now here we again we have 2. We're trying to subtract 9. We are going to need to regroup here. Same as we did last time. In fact, this one, if you look at it, it's identical to C except for the addition of the 3 in the 100,000ths place of the second number. So anyway, we're regrouping to that 2. From the 4, we leave 3, and the 2 we write as 12. Let me take a minute just to make sure you understand what we're doing there. There's no magic going on. It's very simple. From the 300,000, we leave 300,000 from the 400,000. So we're taking 100,000 and bringing it over as 10 10,000s. There were 2 10,000s. We're bringing over 10 10,000s. That's why we have 12 in the 10,000s place. That's the magic of regrouping. Not really magic at all, just, as Arthur Benjamin says, mathemagic. Okay, so 12 minus 9 we can do as 3. And then now in the 100,000s place we're left with a 0. And in this initial digit, you do not write a 0. Because it's just confusing. It makes it seem like there's more to the number that you're not writing. So definitely the convention is to leave it just like that. Our final answer is 30,011. Again, quick check, 422 minus 392. You can probably even look at that and say, yeah, that 30 makes sense there. 30 would be the difference. But even rounding it off to 420 minus 390, or even thinking about it as 42 minus 39, 40, 41, 42, 3 10,000s, that's what we have. It makes sense. Let's look at E. We start off with 0 minus 0, leaving yassa, a 0. And then 3 minus 0 leaves, right, 3. Were you tempted to write 0 again? It's 3. 4 minus 3 leaves 1. 2 minus 2 equals 0. Yes, let's insert the comma while we're here. Now 8 minus 9, common mistake, got to hit this, would be to write 1. So the most common mistake we 4th grade teachers and 3rd grade teachers too see in this kind of subtraction is mentally reversing the digits and saying 8 minus 9 equals 1. Well, 9 minus 8 is 1, but 8 minus 9 is not 1. We, in this case, need to regroup. So we're going to need to regroup with this 8. We go over to the 100,000s place. That 9, we're going to, as we used to say in the old days, borrow 1 and bring it over to the 10,000s place, which would make it 18 10,000s. 18 minus 9, you know your doubles. So 9 and 9 make 18, so 18 minus 9 is 9. And we have 8 we're subtracting nothing from in the 100,000s place. And again, just quick check, 980 minus 90, rounding those off. We could even think of it as 98 minus 9. Or, hey, make life easier. 98 minus 10 is easy to do. What's 98 minus 10? 88, right? We have 89. It checks out. See, there are quick ways to do rough rounding and estimates just to answer that essential mathematical question, does my answer make sense? Or as Eureka puts it, is my answer reasonable? All right, let's finish off this little set here with F. We have 9 minus 9, leave 0. 8 minus 7, got it, 1. 0 minus 0, 0. Now here, 3, can't remove 7 from that 3, right? So here's in our case, I'm going to need to regroup with this 3, go to the next higher place, the 4 there, and regrouping 1 there, so I leave 3, bring it over to the thousands place, making it 13. So now I can subtract 13 minus 7 leaves 6. Now let's place that comma while we're here. 3 minus 3, you got it, 0. And of course 2 minus 1 is 1. Does that answer make sense? 243 minus 137. Well, 43 and 37 are kind of close, right? Let's just do this rough. Let's make life easy. So, like, they're close, so let's just not even worry about them. So, 2 minus 1 is 1. 200,000 minus 100,000, we could say, is 100,000. Is that roughly what we got? See, there are many ways to estimate and make sure your answer is reasonable. Let's go on and finish off with some more standard algorithm subtraction. All right, and here we have G and H, back from number 1, and then we'll go on to number 2. Now G and H, the point here is if you are given addition or subtraction, especially horizontally, written side by side there, it's best to rewrite it vertically. So if you go to take a test, any kind of test you do, or just need to do some subtraction addition in real life, yeah, it's going to help you. It will behoove you to write it out vertically. So let's do that. 2,000. We also want to make sure that when you're writing these out, you are properly lining up the place values. It would be a mistake for me to place the 9 in 920 under the 2 here, right? It's 900. It should go over the 4, under the 4 rather, in the hundreds place. All right, so I've lined up my place values. Otherwise, you will get some wackadoodle answer for sure. All right, looks good. Let's subtract. 1 minus 0 leaves 1. 3 minus 2, got it, 1. Now when I go to take 9 away from 4, I don't have 9. I need to regroup here. All right, so I need to regroup with this 4. Go to the next highest place, leaving 1 there. Regroup it over here. So I now have 1400s. 1400s minus 900s leaves 500s. And the 1 in the thousands place, I am subtracting nothing from. Insert my comma. Beautiful. Now here with longer numbers, up to 6 digits, I need to also be careful to line up my place values. I'm going to try to write as neatly as I can here. You should too. So easy way to make mistakes there is to not have your place values lined up. And even when we get through multiplication, I'd say especially in division, we teachers see lots of errors in division regarding place value. Unless you're really careful about it, then you won't make any mistakes. Ever. You'll be perfect. Let's subtract now. You ready to go? All right. 1 minus 0 leaves 1. 3 minus 0, 3. We get to hundreds place. We only have 4. We can't subtract 8, right, without regrouping. So let's do that regrouping. And you notice they've been nice to us. We haven't had to regroup across zeros yet. It's coming, though. Okay, so the 2, we will leave 1,000 there and bring it over as 10 hundreds. With the 400s we have, we now have 1400s. 1400s minus 800s. You got it, leaves 600s. From the 1, we're subtracting 0, leaving 1. Let's insert that comma while we're here. 9 minus 2. You got it, 7. 8 minus 5 leaves 3, and this answer does make sense. You can even just do 89 minus 52 and get 37. You could even go really rough, like we said. This is about 900,000 minus 500,000. It's 400,000. Doesn't our difference here round up to 400,000? The answer makes sense. Hallelujah. All right, number 2. What number must be added to 14,056 to result in a sum of 38,773. What? Okay, so that might seem confusing, but watch, this is the beauty of math. When it says what number, let's call that unknown number. We don't know what it is just yet. Let's call that number x. So we're going to add a number. It says what number, x, must be added to 14,056 to result in, a sum, to result in a sum, in other words, to be equal to 38,773. Well, we know that addition and subtraction are inverse operations, so you can move the numbers around, we know, and get the same sum or difference by changing things there. For example, let's just look at an easy one so you could see. For example, if I asked you like, hey, and this is totally separate from this, just to get the logic of what we're doing down here. If I said, okay, well, some number plus 2 equals 5, well, you'd probably look right at that and be like, well, it's 3, right? But what you did in your head was you said, okay, well, 5, the difference between 5 and 2, the difference between 5 and 2 is 3. And that means that unknown number in the beginning there, that x equals 3. Now again, this is unrelated to what we're being asked in number 2 directly, but this is the logic we're using. So what we do is we took the sum, subtracted the known addend to find the unknown addend. Okay, so if we take the sum here, even though the numbers are bigger, it makes no difference. It's the same logic. We take the sum here, 38,773, and subtract the known addend, which is 14,056. We will get the unknown addend. I'm taking some time on this to show you the logic because you will have lots of this coming up. So make sure you do understand this, how the logic of this kind of question works, because you will be seeing lots of it. So if you're confused, rewind, go back, and go over that whole x plus 2 equals 5 thing again. Maybe come up with your own examples. All right, so now we're ready to find x, that unknown addend. All right, we start right off. Ooh, hitting us with the regrouping right in the ones place. We have 3. We cannot subtract 6 from that without regrouping. If you wrote 3, yep, you switched the digits. All right, so we need to regroup that 3 over from the tens place, leaving 6 there. We bring 10 over to the ones place. Now we have 13 ones. Minus 6 ones leaves 7 ones. 6 minus 5 is 1, yes. 7 take away 0. Yeah, leaves 7. 8 minus 4. We can do that. It's 4. We know our doubles. Insert our comma while we're here. And 3 minus 1 equals 2. Makes sense, right? 40,000 minus 10,000. Is that a good way to round it? It's 30,000. See, it's pretty rough. You'd pretty well have to say, round it off more to, this is 39,000. 39 minus 14 is 25, and this does round off to 25,000 to do a quick mental check for the reasonableness of your answer. So the number that must be added, I can actually just go over here. Instead of writing out a full sentence, I can just say x from this equation up here. X is 24,717, or you could write a sentence saying that 24,717 must be added to blah, blah, blah to result in the sum of blah, blah, blah. All right, with all that blah, 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 let's go on to number 3. Okay, number 3, same thing. We're subtracting. This is where we start to do something more like what you have in real life. Like we said, word problems. Life is a word problem. No one will come up to you and say, hey, what's blah, 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 1,000 minus this, and, but this kind of thing is the sort of times that people in real life have to do math. So let's do some real life math. Our instructions are to draw a tape diagram to model each problem, and that goes for 3 through 5 here. Use numbers to solve, and write your answers as a statement. Check your answers. Okay. And so that means we have several things to do in each question here. We need to draw a tape diagram, do the math, also known as use numbers to solve, and then write a sentence, a little statement, just saying, this is the answer to the question. And then we need to check our answers, which we do, of course, by rounding and estimating, which we have lots of practice in. We will rock this. Let's do it. Okay, an elementary school collected 1,705 bottles for a recycling program. A high school also collected some bottles. Both schools collected 3,627 bottles combined. How many bottles did the high school collect? This is just like what we did in 2 there, isn't it? So the unknown is the high school. Okay, so we know the elementary school amount, 1,705. If added to the high school amount, let's call it, sorry, that should be a plus. Plus, let's call it H, will give us 3,627. Okay, so we know from number 2, we've learned if we subtract this addend from the sum, we will get the unknown addend. And in fact, that's exactly the whole point of the tape diagram. The tape diagram is to help you see what you're supposed to do. So this is all the bottles right here, okay? And so what's our total for bottles? Well, it's actually right there above it, but I'll write again. 3,627 is all the bottles. And we know a part of that. We know the elementary school part, and I'm just going to draw a line somewhat randomly here. We know the elementary school part is 1,705. What we're trying to find is this part. This is the high school part, which we're calling H. All right, so now we know what we're trying to find. And don't you see how we have the whole minus the part will give us the unknown part. So let's go ahead and do that there math. We read, we drew. Let's do the math writing part. We have 3,627, and we are subtracting 1,705. Okay, so 7 minus 5 we can do. That leaves 2. 2 minus 0, again 2. Now 6 minus 7, if you're too quick and you write 1, that means you reverse the numbers, switch them around. If we only have 6, we can't take 7 without regrouping here. So we will need to regroup this 6, going over to the next highest place, leaving 2 thousands there, bringing it over as 10 hundreds with the 6 hundreds we already have, so 16 hundreds minus 7 hundreds leaves 9 hundreds, and then 2 thousands minus 1,000 leaves 1,000. Insert our comma. And then we of course have to ask, does that make sense? Well, this time we are to check our answers, so let's do a real rounding. I'm assuming at this point that you can round numbers no problem. If not, go back to lesson what have you. All right, so 3,627. Well, if we round it to the nearest 1,000 on these, we could try that. It's easiest. May not always work. Let's give it a shot. So to the nearest thousands, we have 3,000. The 6 tells us it's past the midpoint, so we'd round up to 4,000. And we're subtracting, we'd round this up to 2,000, and we would receive as an answer something around, well, this actually does round to 2,000, doesn't it? 1,922. Okay, so that's an estimate to make sure our answer is reasonable. The true check, though, is where we take the difference, the 1922 here, and add it to the diminuend of 1705, and we should get the subtrahend, that first number. And I've noticed a tendency among students when doing a subtraction check just to automatically write what the answer should be rather than doing the actual addition. And while that's a very hopeful way, it is not always accurate. So to be accurate, we have to kind of mentally cover up what we did before and just really add to make sure our answer checks out. Okay, so you see where if we take the difference, add the number we subtracted, we should get the number we started with there. All right, so let's try it. And again, I'm not looking over there and just copying that number. I want to actually add to make sure it's what I get. 2 and 5 make 7. Remember, we're adding now. 2 plus 0, 2. 9 plus 7, 16. We'll place the 6, regroup the 1. 1 and 1 and 1 make 3. And we insert a comma. Now, if you got anything other than what you should have, and ours checks out, does that tell you where the problem is? It actually doesn't. You could have copied one of the numbers down wrong. You could have made an error in subtracting. You could have made an error here in your addition check. So it doesn't tell you where the problem is. It just tells you there is a problem. And forsake not the writing of the statement. Yes, write your answers as a statement. So we are answering the question, how many bottles did the high school collect? So let's write a statement that says that. The high school collected now make sure we get the right number here, not the 3,627, that's the whole, not the 1,705, that's the elementary school. It was this H that we solved for, that's the 1,922. 1,922 what? Yes, bottles. Good job, high school. All right, and now we're ready to roll on to number 4. Okay, here we are, number 4, and again, we're just going to do these without so much explanation because you know what you're doing now. So this computer shop sold $356,291 worth of computers and accessories. So it's computers and accessories together. Keep that in mind. It sold $43,720 worth of accessories. How much did the computer shop sell in computers? All right, so important thing here is if you're not sure, like what we're talking about accessories, it kind of doesn't matter for a sense of doing the math. It'd be good to know, but you could just, computers and something. And then, all right, accessories, all the things that go with the computer, like power cords and sleeves to put them in and such. All right, so we want to find just the computers. Okay, so the tape diagram will show you clearly what we're going to do. Hey, look, we know we're doing subtraction here. That's what we're studying, but you never know. They might throw us a curveball or something. So the whole amount sold, the whole tape here, computers and accessories together, is $356,291. Okay, so now we know a portion of that, and we can kind of tell by glancing at the size of these numbers that we're talking about the smaller portion here. This here is accessories. And we know that part is $43,720. And so what we're trying to find here is that's right, the amount of computers sold. the value of the computer, so which we'll call C for computers. So you can see how we have the whole, we're going to take away the part to find the unknown part. So indeed, let's do that. 356,291, and we are subtracting from that the known part of $43,720 in accessories. That will give us the amount of computers. So 1 minus 0 leaves 1. 9 minus 2, we can do that, 7. Now here you only have 2. Can't subtract 7 without regrouping, so let's regroup with that 2. Go over to the 6, leaving 5 thousands. Bring it over as 10 hundreds with the 2 hundreds we already had. So 12 hundreds minus 7 hundreds leaves 5 hundreds. 5 minus 3 is 2. Let's place that comma while we're here. 5 minus 4, 1. And the 3 we're subtracting nothing from, so it's 3. And the answer makes sense. We can do kind of that quick. 35 minus 4 leaves 31. Okay, this is making sense, but let's do the actual check. We are going to take the difference, the $312, $1,571, and then add to it, so that's the amount of computers we're thinking, add to it the amount we had in accessories, 43,720, and we should get the total of computers and accessories we started with. Let's see what happens. 1 plus 0, 1. 7 and 2 make 9. Don't forget we're adding. 5 plus 7, got it, 12, right? Place the 2, regroup the 1. 1 and 2 and 3, yep, 6. Let's place that comma while we're here. 1 plus 4 is 5, and 3 we're adding nothing to is 3. Did we get what we started with? Yes, we did, and now we will write our statement. The shop sold. We need a dollar sign here on this number because now we're not just calculating, we're talking about an actual dollar amount. So how much did I sell on computers? That was this, right? Okay, $312,571 in computers. That's a tidy sum. Period. All right, we did our model tape diagram, we subtracted, we did a complete check, we wrote our statement. We're done. Let's roll on like a river to number 5. All right, and 5A and B are a true two-part question in that you need the answer from part A in order to do part B. So let's dive right in. The population of a city is 538,381. In that population, 148,170 are children. So question A is how many adults live in the city? Well, obviously it's the portion which are not categorized as children. So our tape is going to be the whole thing is the whole population, right? That whole tape is the whole population. So we'll draw a little bracket up here, leaving just enough room to write that number in. 538,381 is the entire population, and we know a relatively smaller portion of it there is children. So this is children, and we know what that is. That's 148,170 children. And this is our unknown part, right? Let's call it A for adults. We want to find how many adults. And the tape diagram is beautiful in that it shows you we have the whole. and we're subtracting the known part to find the unknown part. The tape diagram shows you it's subtraction. So let's subtract. So we'll be subtracting 538,381, and from that we're taking 148,170. So let's do it. 1 minus 0 leaves 1. 8 minus 7, 1 again. 3 minus 1, got it, 2. 8 minus 8, yeah, 0. Place that comma. 3 minus 4 is 1. Oh, no, don't be fooled. Yep, don't switch those numbers. We have 3. We can't take away 4. Let's regroup with that 3. Going over, leaving 4 in the hundred thousands. Bring it over as 10 10,000s. So 10 10,000s and the 3 that were already there. 13 10,000s minus 4 10,000s leaves 9 10,000s. And then 4 minus 1 is 3. Alright, and just quick glances, this answer makes sense, even if you just round it to the nearest 100,000. 500,000 minus 100,000 is 400,000. That works. Well, let's do the full-on check. So you take the difference, the answer you got there, the 390,211, and then we will add what we subtracted, the diminuend, 148,170. And I'm doing my darndest here to line up those place values, otherwise you get everything all haywire. And when we add these together, we should get the number we started with. Remember, don't just copy it. It's a common mistake. Let's actually add. 1 plus 0 is 1. 1 plus 7, 8. 2 plus 1, 3. 0 plus 8 is 8. And while we're here, let's place that comma. 9 plus 4, 13. We place the 3, regroup the 1. 1 and 3 and 1 make 5. Is that the number we started with? Yes, indeed it is. So now we could say 3. Make that 3 beautiful. 390,211 adults live in the city. All right. Excellent. Ready to go on. Now remember, you'll need that number to complete 5B. Let's do it. And here we go with 5B. So now we have to do a little bit of thinking here. 186,101 of the adults are males. Of the adults. How many adults are female? Okay, and I copied from above what the population is, and then I copied from above our math showing us how many adults we have, okay? So now we're working with, this is the number of adults here. This is the number we need to work with, not that whole population. The number of adults, because we're trying to figure out how many female adults we have. So when we draw our tape diagram, the whole tape is not the whole population over 538,000. It's the adult population. That makes sense? Good. Knew it did. So it's that 390,211 adults. And the part that we do know, it seems about roughly half-ish, is the male portion. And so that is 186,101 males. And what we're trying to find here This unknown part we'll call F. That's the number of females. And you can see from the tape diagram it shows we know the whole. We have a known part. We're subtracting to find the unknown part. So let us do that. We will take the 390,211 adults and subtract from it the portion that is male, 186,101, and that will give us the number of females. So let's do that. 1 minus 1 leaves 0. 1 minus 0, 1. 2 minus 1, yep, leaves 1. Now here we have 0 subtracting 6. The mistake would be to write 6, right, reversing the numbers. But we have 0. We cannot take 6 away without regrouping. And so we will regroup with this 0, going over to the 10,000s place, regrouping one of them, leaving 8 10,000s, bringing it over here as 10,000s. 1. And that will, with the 0 we had as 10,000s, 10 minus 6 leaving 4, and we'll place that comma while we're here. 8 minus 8 leaves 0, and 3 minus 1 is 2. Okay, and a quick check. 400,000 minus 200,000 is 200,000. Rounding those numbers quickly in my head. Okay, we'll do the actual check, but before you even get to the actual check, I like to run that does my answer make sense check, because there's no point in doing an actual check if your answer makes no sense, right? You already know you have a problem. So if we take the difference we got, the number of females, 204,110 females, and add to it the number of males, 186,101, we should get the whole adult population. Let's see if we do. Remember, don't just copy the number you know it should be. Actually add. Otherwise you're wasting your time. 0 plus 1 is 1. 1 plus 0 likewise is 1. 1 and 1 make 2. 4 and 6 make 10. Regroup the 1. I might as well place that comma while I'm here. 1 and 0 and 8. 9. 2 and 1 are 3. Beautiful. Does it check out? It does. That means our answer is correct here. 204,110 females. So we can say 204,110 adults. This is our statement. Actually answering the question is always good, right? Are female. All right, can you believe it? Homework time is done. Great job. See you next time on Homework Time.